In 2004, the Occupational Safety and Health Administration, or OSHA, reported a total of 85,307 violations across all industries. Of these, 61,018 were classified as serious and 747 as willful. There were 5,703 workplace fatalities in that year. Focusing on the electrical industry specifically, the following violations were noted. Willful violations included 38 instances of violation 1926.501 related to full protection, 30 instances of violation 1910.147 concerning lockout/tagout procedures, and 22 instances of violation 1910.212 pertaining to machine guarding. Serious violations in the electrical industry comprised 5,389 instances of violation 1926.501 full protection, 3,222 instances of violation 1910.147 lockout/tagout, 2669 instances of violation 1910.212 machine guarding, 2212 instances of violation 1910.305 electrical wiring, 1935 instances of violation 1910.219 mechanical power transmission, and 1908 instances of violation 1926.1053 ladders. Let's delve deeper into each of these violation categories. Firstly, full protection. Violation 1926.501 addresses the requirements for protecting employees from full hazards in the construction industry. This standard mandates the use of guardrail systems, safety net systems, or personal fall arrest systems when employees are working at heights of 6 feet or more above a lower level. Full protection also includes proper training for employees on how to recognize fall hazards and use fall protection equipment correctly. Employers are required to assess the workplace for fall hazards and implement appropriate control measures to prevent falls. Secondly, lockout/tagout. Violation 1910.147 pertains to the control of hazardous energy during servicing and maintenance of machines and equipment. This standard requires employers to establish procedures for isolating energy sources and preventing the unexpected startup or release of stored energy. Lockout involves physically locking out energy isolating devices, while tagout involves attaching warning tags to these devices. Employees must be trained on the proper lockout/tagout procedures, and the procedures must be followed whenever servicing or maintenance is performed on equipment. Thirdly, machine guarding. Violation 1910.212 focuses on protecting employees from hazards created by moving machine parts. This standard requires that machines be equipped with guards to prevent employees from coming into contact with points of operation, ingoing nip points, rotating parts, and flying chips or sparks. Guards must be designed and constructed to prevent access to hazardous areas and must not create additional hazards. Employees must be trained on the hazards associated with the machines they operate and the importance of using machine guards. Fourthly, electrical wiring. Violation 1910.305 covers the general requirements for electrical wiring methods and components in the workplace. This standard requires that electrical wiring be installed and maintained in accordance with the National Electrical Code, or NEC. Wiring must be protected from physical damage and must be properly grounded to prevent electrical shock hazards. Electrical equipment must be approved for its intended use and must be installed in a safe manner. Fifthly, mechanical power transmission. Violation 1910.219 addresses the hazard associated with mechanical power transmission apparatus such as belts, pulleys, gears, and shafts. This standard requires that these components be guarded to prevent employees from coming into contact with them. Guards must be designed and constructed to prevent access to hazardous areas and must not interfere with the operation of the equipment. Employees must be trained on the hazards associated with mechanical power transmission equipment and the importance of using machine guards. Finally, ladders. Violation 1926.1053 sets forth the requirements for the safe use of ladders in the construction industry. This standard requires that ladders be inspected for defects before each use and that damaged ladders be removed from service. Ladders must be placed on stable surfaces and must be used at the proper angle. Employees must be trained on the proper use of ladders and the hazards associated with ladder use. The high number of violations related to fall protection, lockout/tagout, and machine guarding highlights the importance of these safety measures in preventing workplace injuries and fatalities. Employers must prioritize these areas and implement comprehensive safety programs to ensure that employees are protected from these hazards. Regular training, hazard assessments, and equipment inspections are essential components of an effective safety program. Furthermore, it is crucial for employers to foster a safety culture in the workplace, where employees are encouraged to report hazards and participate in safety initiatives. By working together, employers and employees can create a safer work environment and reduce the risk of accidents and injuries. The data underscores the need for continuous improvement in safety practices across all industries, particularly within the electrical sector where these violations pose significant risks. Understanding these common violations helps to target training and prevention efforts more effectively. The NEC plays a vital role in electrical safety, providing detailed standards for safe electrical installations. Compliance with the NEC is essential for preventing electrical hazards such as shocks, fires, and explosions. The code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is regularly updated to reflect new technologies and safety practices. Article 90.1 of the NEC outlines the purpose of the code, which is the practical safeguarding of persons and property from hazards arising from the use of electricity. The NEC is not intended as a design specification nor an instruction manual for untrained persons. It is intended to be used by qualified electrical professionals who have the knowledge and experience necessary to apply the code correctly. Chapter 1 of the NEC contains general requirements that apply to all electrical installations. These requirements cover topics such as wiring methods, grounding, and overcurrent protection. Chapter 2 of the NEC covers wiring and protection. This chapter includes requirements for conductors, cables, raceways, and overcurrent protective devices. Chapter 3 of the NEC covers wiring methods and materials. This chapter includes requirements for different types of wiring methods such as rigid metal conduit, electrical metallic tubing, and non-metallic sheet cable. Chapter 4 of the NEC covers equipment for general use. This chapter includes requirements for electrical appliances, luminaires, and other types of electrical equipment. Chapter 5 of the NEC covers special occupancies. This chapter includes requirements for electrical installations in hazardous locations, healthcare facilities, and other special occupancies. Chapter 6 of the NEC covers special equipment. This chapter includes requirements for electrical equipment such as elevators, electric signs, and electric welders. Chapter 7 of the NEC covers special conditions. This chapter includes requirements for electrical installations in areas subject to corrosive conditions, high ambient temperatures, and other special conditions. Chapter 8 of the NEC covers communications systems. This chapter includes requirements for telephone systems, data communication systems, and other types of communication systems. Chapter 9 of the NEC contains tables and examples. This chapter includes tables of conductor ampacities, conduit fill, and other information that is useful for electrical calculations. Grounding is a critical aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip over current protective devices and prevent electrical shock hazard. The NEC requires that all electrical systems be properly grounded. Article 250 of the NEC covers grounding and bonding. This article includes requirements for grounding electrodes, grounding conductors, and bonding conductors. Grounding electrodes are used to connect the electrical system to the earth. Common types of grounding electrodes include metal water pipes, ground rods, and concrete encased electrodes. Grounding conductors are used to connect equipment and enclosures to the grounding electrode. Bonding conductors are used to connect metallic parts of the electrical system together to ensure that they are at the same electrical potential. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protective devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. The NEC requires that all electrical circuits be protected by overcurrent protective devices. Article 240 of the NEC covers overcurrent protection. This article includes requirements for the selection and installation of overcurrent protective devices. Circuit breakers are designed to trip automatically when the current in a circuit exceeds a certain level. Fuses are designed to melt and open the circuit when the current exceeds a certain level. Both circuit breakers and fuses must be rated to interrupt the maximum available fault current at the point of installation. Arc flash is a dangerous phenomenon that can occur when there is a short circuit in an electrical system. Arc flash events can produce intense heat, pressure waves, and flying debris, which can cause serious injuries or fatalities. Employers are required to protect employees from arc flash hazards. Article 110.16 of the NEC requires that electrical equipment be marked with warning labels that indicate the potential arc flash hazards. The NFPA 70E standard provides guidance on how to protect employees from arc flash hazards. This standard includes requirements for arc flash hazard assessments, personal protective equipment, and training. Regular inspections and maintenance of electrical equipment are essential for preventing electrical hazards. Electrical equipment should be inspected regularly for signs of damage, wear, and corrosion. Any damaged or defective equipment should be repaired or replaced immediately. Maintenance should be performed by qualified electrical professionals. Employees should be trained on how to identify electrical hazards and how to work safely around electricity. Training should include information on the hazards of electricity, safe work practices, and the use of personal protective equipment. Employees should also be trained on how to respond to electrical emergencies. The OSHA regulations are in place to protect workers from hazards in the workplace. Employers are required to comply with these regulations. Failure to comply with OSHA regulations can result in fines, penalties, and even criminal charges. OSHA conducts inspections of workplaces to ensure that employers are complying with the regulations. Employees have the right to report safety hazards to OSHA without fear of retaliation. The information presented here serves as a reminder of the importance of electrical safety in the workplace. By understanding the common violations and taking steps to prevent them, employers and employees can create a safer work environment for everyone. Let's examine some specific scenarios and best practices related to the violations mentioned earlier. For fall protection, ensuring that all workers at heights above 6 feet have appropriate fall protection equipment and training is paramount. This includes regular inspection of harnesses, lanyards, and anchor points. Implementing a system for documenting these inspections is also crucial. In terms of lockout/tagout, written procedures specific to each piece of equipment should be readily available and followed meticulously. Training should cover the specific energy sources and isolation points for each machine. Verification of energy isolation before commencing work is essential. With machine guarding, regular inspections should ensure that guards are in place and functioning correctly. Any missing or damaged guard should be reported and replaced immediately. Training should cover the hazards associated with each machine and the proper use of guards. Concerning electrical wiring, regular inspections should look for damaged or exposed wiring, loose connections, and overloaded circuits. Any deficiencies should be corrected by qualified electricians. Grounding systems should be tested periodically to ensure their effectiveness. Regarding mechanical power transmission, guards should be inspected regularly to ensure they are securely in place. Lubrication and maintenance of moving parts should be performed according to manufacturer's recommendations. Finally, for ladders, workers should be trained on proper ladder placement, climbing techniques, and weight limits. Ladders should be inspected before each use, and any damaged ladders should be taken out of service. 3-point contact should be maintained at all times when climbing a ladder. It is also important to emphasize the role of continuous improvement in electrical safety. Regular review of safety procedures, incident investigations, and feedback from workers can help identify areas for improvement. Staying up to date on the latest electrical safety standards and best practices is also essential. Consider the economic impact of electrical safety violations. In addition to the direct cost of fines and penalties, there are indirect costs such as lost productivity, workers' compensation claims, and damage to equipment and property. Investing in electrical safety can save money in the long run by preventing accidents and injuries. Let's discuss some specific examples of how these violations can occur and how to prevent them. For instance, a worker may be using a ladder that is not properly secured, leading to a fall. To prevent this, ensure that all ladders are placed on stable surfaces and are secured at the top and bottom. Another example is a worker may be performing maintenance on a machine without properly locking out the energy source, resulting in an unexpected startup. To prevent this, ensure that all energy sources are properly locked out and tagged out before any maintenance is performed. A worker may be operating a machine without proper guarding, leading to contact with moving parts. To prevent this, ensure that all machines are equipped with guards that are in good working order. A worker may be working with exposed electrical wiring, resulting in an electrical shock. To prevent this, ensure that all electrical wiring is properly insulated and protected. A worker may be using a tool that is not properly grounded, leading to an electrical shock. To prevent this, ensure that all tools are properly grounded and inspected before use. By addressing these potential hazards and implementing the appropriate safety measures, employers can significantly reduce the risk of electrical safety violations and create a safer work environment for their employees. Effective communication is crucial for promoting electrical safety. Regular safety meetings, toolbox talks, and signage can help keep workers informed of potential hazards and safe work practices. Encouraging workers to report safety concerns without fear of reprisal is also essential. In conclusion, electrical safety is a critical aspect of workplace safety. By understanding the common violations, implementing effective safety measures, and fostering a strong safety culture, employers and employees can work together to prevent accidents and injuries and create a safer work environment for everyone. Remember that compliance with OSHA regulations is not just a legal requirement, but also a moral imperative to protect the health and safety of workers. The information presented here is intended to provide a general overview of electrical safety and should not be considered a substitute for professional advice. Always consult with qualified electrical professionals and refer to the applicable codes and standards for specific guidance on electrical safety matters. Further, consider the role of technology in improving electrical safety. Advances in sensing, monitoring, and automation can help detect potential hazards and prevent accidents. For example, wearable sensors can detect when a worker is exposed to excessive voltage or current, and automated systems can de-energize equipment in the event of a fault. Investing in these technologies can enhance electrical safety and reduce the risk of injuries and fatalities. Also, the impact of human factors on electrical safety should not be overlooked. Fatigue, stress, and complacency can all contribute to errors and accidents. Employers should implement measures to address these human factors, such as providing adequate rest breaks, managing workload, and promoting a culture of safety awareness. Encouraging workers to speak up when they are feeling fatigued or stressed can help prevent accidents. Finally, consider the importance of continuous learning in electrical safety. The electrical industry is constantly evolving, with new technologies and standards emerging all the time. Employers should provide ongoing training and education to ensure that workers stay up to date on the latest electrical safety practices. This can include attending workshops, conferences, and online courses.